Okay. Chapter 1, visualize, sketch, and label. We're going to show a coordinate system. Which way is plus, which way is minus, up to you. But some are easier to work with than others. We talked about that last time. We've talked about space, position, displacement, and sometimes we talk about distance. A little different, but not too bad. Now we're going to talk about velocity. Maybe it's the easiest one in some ways, but velocity is how fast are you going and in what direction. So let me just show you this a little bit, and then I think you'll get it. And if not, check with me or whomever is teaching it and your classmates. Let's talk about direction first. For one dimension along a straight line, which can be horizontal, it can be vertical, it can be along a sloped surface like this. If this were a table that we're sliding up and down on a ramp, that's one dimensional. And you have to choose one direction to be positive and the other negative. Down positive, up negative, up positive, down negative. Either way here too. So you'll get to that later and we'll be clear about that. For two dimensions, like the last one, we have to choose x and y. We won't do a lot of that until a little bit later. But x and y, this could be y, this is x, positive, positive. Or I could flip it so down is positive, or I could turn it, I could go like that, whichever way. We're just cutting up the board. I want to also start this by talking about how fast. So in chapter 2, which is not too bad, but do the exercises, because even though you might be familiar with them, just see how fast you can do it, because you're getting yourself so that you're really quick at it, so you can deal with the puzzles and all. We want to talk about units in chapter 2 and how much does a number mean? I mean, how far away is 4 meters? Can you visualize that? 4 real long steps or maybe 8 steps. How fast? So we often use in physics books a meter per second. So that's a long step, and a second's 1001, 1002. So it'd be 1001, 1002, something like that. A meter per second would be something, kind of a slow walk. We often walk a little less than 1.5 meters per second. That's kind of. So when we talk about a meter per second, that is approximately 2 miles per hour. If you want to be picky, it's closer to 2.2 miles every hour. So we're going to talk about, think about how much do these numbers mean? That's going to train our physics. We're not just going to be doing math. We're going to connect those two. Now, most people around the world use kilometers. So 1 kilometer is approximately, really roughly, half a mile. Or it's really closer to 2/3 of a mile. And it's actually in between 0.62, or if you want to be picky, 621 miles. So 1 kilometer per hour is super roughly half a mile per hour, or super roughly 2/3 of a mile per hour, or 0.621 miles an hour. You can think about it with your car and things like that, and you'll have plenty of exercises for that. So we can talk about speed and how fast, but which way are we going? So let's look at an object for one dimension. Well, let's just go this way for now. You'll have plenty of exercises doing the other thing. So I could show you an object. Again, a simple square or circle will do. And I want to show you which way it's moving. So this object doesn't have to start at rest. I mean, most things around us do. But remember, when you start a video or a new scene in a movie, something could already be running, a car could be moving. So I'm going to go like this. Now that tells you that it's moving to the left. Now if this is state 1, I'm going to label that V1, not just V, V1. And I can give you a number, something. And then something happens, it goes whatever it goes, and I look again, and I look over here, and I've got V2. state 2. Earlier, later. Now the way I've drawn it, if I'm careful, I've shown you that it's actually going slower because my arrow is shorter. If I wanted to be real careful, I could measure it, and if it's half as fast, I make it half as short. But sometimes we just sketch it. And maybe it stops. V3 is 0. And it could just sit there. If it just sits there, I could say V4 is 0. And then maybe it heads back. Maybe it's here. But now it's going this way. And maybe it's going really fast. I don't know. Wow. Oops, that's not V4, that's V5. So it gets a little crazy. And then it's going this way. And maybe then it goes, well, I'm going too fast. Slow down. V6. So that's how I show the, now you could draw the arrow up above it. We often draw it right along it. And I'll show you that more in 2 dimensions. So it's not too bad. A longer arrow means you're going faster. That arrow's going really fast. I could say how much with some numbers. And then I have to say the direction. Well, I could say left and right, but when we do the math equation stuff, we need a plus or a minus. So again, my good old blue and red, if I call this positive x direction, then I'd say this is a negative velocity, a little less negative, 0, must be having some coffee, maybe a little latte. And now it's got a positive velocity and now a little less positive velocity. I kind of run that video in my head, although I don't really know what happened from here to here, but I have this. If, however, I wanted to choose positive this way for whatever reason. For blue, this would be negative, I don't know, 10 meters per second. For red, it would be positive 10 meters. We'd still both mean left at 10 meters per second. But we have to be careful of that plus and minus, that's all. And it's just a habit. It really does matter. So for red, positive, positive, 0, 0, negative, negative. And that's kind of all there is to the velocity. One thing that gets a little tricky, and you'll really appreciate it more in as you get to Newton's laws, if something is moving around, say on a circle, that's 2-dimensional. Now that image could be moving around on the floor. It's just I'm drawing it here, so I'd be looking down on the floor and I put it up here. So this could be all horizontal, no vertical. Or it could be up and down and side to side. That could be vertical, or it might not. We just have to think about it physically. But you'll have time. You do have to put time into it. And if an object is here, whatever, 1, and it's traveling, even at the same speed, I'd say V1, and then over here, I draw it tangent to the path. So just as if I put a stick that just kisses the path, and if it's the same speed, I'll draw the same length arrow, V2, but I change direction, and here I'd be going this way, tangent to the path. I don't actually travel that way, I travel this way. It's changing, but V3, V4, V5, and that's what we mean by tangent to the path. V6. How much, plus, minus, we'll put those details in. We just need to see the picture first. V7, V8, and that, oops, V8. And it could be getting faster or slower or whatever it does. So V8. So that's what we mean by tangent to the path. And then you could do crazy stuff. You could just, whatever, it doesn't matter if your path is like, this. Then usually when we go into corner, we're going to slow down. So let's see, I don't know. I could start from rest, but then I got to pick up speed. V2, V3, V4 right along there since it's kind of straight. V5, etc. All along, and then when you cross that way again, now you got that. Just tangent to the path. How do you break that down into X and Y parts? That's chapter 5, so we won't worry about that too. We'll build up to that. So when you're comfortable with these details, we can build up to doing the real deal. And when you're getting into chapter 3, 4, and 5, you're doing your physics. And if you can get 7 and 8 in before your class, you're going to be insanely prepared. So I think that's all I have to say right now, because acceleration is where it gets interesting too. So for now, just draw it and label it time 1, time 2, time 3, time 4, time 5, time 6. Subscript it, and we'll worry about the pluses and minuses and all that stuff later. No calculations right now. And that's it.